Hello everyone, this is Ilker Boz here, a research scientist at the Virginia Transportation Research Council. I hope everyone is well and I welcome you to VDOT Balanced Mix Design Just-in-Time training. In this presentation, we are going to go over the basics of BMD concept. What is balanced mix design? Balanced mix design is asphalt mixture design methodology that utilizes performance tests on appropriately conditioned specimen that addresses multiple modes of distress taking into consideration mix aging, traffic, climate, and location within the pavement structure. Why is BMD needed? The answer to this question is simple. We need BMD to improve performance of asphalt mixtures so that we achieve longer lasting pavement. The current design, SuperPave design, initially had tiered approach that included performance testing. However, because of the concerns associated with the routine use of performance tests, such as complexity and time needed to run the tests, as well as the cost of equipment, the design parts of the SuperPave that included performance testing are largely abandoned. Today, what we have is the volumetric design part of the SuperPave methodology, and the volumetric design has shortcomings. First, it is not a direct indication of performance. Second, it cannot capture the impact of binder grade and additives on the mixture performance. When we say additives, we are referring to polymers, fibers, chemical additives such as Vormix additives, and nanomaterials. Third, aggregate specific gravity is not checked often, and any significant variation within a single year due to the site's geology and mining operation will result in inaccurate volumetric properties in asphalt mixtures. In addition, any variations, even small ones, in aggregate specific gravity values within the established precision estimates may significantly result in changes in the volumetric properties and hence may impact the mix design or production decisions. Fourth, volumetric design cannot capture the impact of recycled materials, RAP, RAS recycling agents on mixture performance. Finally, the assumptions we make in calculating volumetric parameters in mixtures with recycled materials, whether low or high, are based on assumptions may not be entirely true or happening with mixtures. For example, the assumption of full blending between wrap binder and virgin binder, and the assumption of how we calculate wrap aggregate specific gravity. I would like to add a caveat here that BMD is not a magic tool. It helps us have a good quality mix, but the ultimate performance will also depend on factors such as the condition of existing pavement and construction practices. If these are not optimal, we would not get the desired performance, no matter how good of a mix we design. As per AASHTO Spec PP105, there are 4 different approaches to BMD concept, and in the next 4 slides, we will briefly go over these approaches. Approach A, volumetric design with performance verification. In this approach, the current volumetric mix design method is used to determine an optimum asphalt binder content. Then the mixture is tested with selected tests to assess its performance against rotting, cracking, and moisture damage at the optimum binder content. If the mix design meets the performance test criteria, the job mix formula is established and production starts. If not, the entire mix design process is repeated using materials or mix proportions until all of the volumetric and performance criteria are met. Approach B, volumetric design with performance optimization. In this approach, the current volumetric mix design method is used to determine an initial optimum asphalt binder content. Then the mixture performance tests are performed on mix design at the initial optimum asphalt binder content and 2 or more additional contents. The asphalt binder content that satisfies all of the performance criteria is finally identified as the optimum asphalt binder content. Approach C, performance modified volumetric mix design. In this approach, the current volumetric mix design method is used to establish initial component material properties, proportions, and binder content. Then the performance test results are used to adjust either the initial binder content or mixed component properties or proportions until the performance criteria are satisfied. For this approach, the final design may not be required to meet all of the SuperPave volumetric criteria. Approach D, performance design. In this approach, mixture components and proportions based on performance analysis with limited or no requirements for volumetric properties Minimum requirements might be set for asphalt binder and aggregate properties with use of this approach. This figure shows the survey results conducted towards the end of 2020 by ANCAT on the current state of practice on BMD. We see here 2 states are exploring approach D, 3 states use approach C, the rest, except Virginia, uses approach A. For Virginia, I think for the 2021 construction season, we have all approaches on the table as an option. One important note for those who attended the latest BMD technical committee meeting, the information given on the current state of BMD practice in the meeting was based on VTRC's report, which will be published soon. The information presented in the report is different than information shown in this figure. This is because the information provided here is based on a survey from 2020, and the information provided at the technical meeting or in the report is based on a survey from 2018. We have seen that performance tests are central to BMD concept, and AASHTO PP105-20 guide us on the modes of distress and associated performance tests to be considered in BMD. We will briefly go over the test in the next slides. To test overall durability of asphalt mixtures, we don't have much a choice. The test method outlined in AASHTO PP105, known as Cantabro test, is used to evaluate the overall durability of asphalt mixtures. The Cantabro test is part of V.BMD process, and we will hear more about it in one of the presentations today. To test rutting potential of asphalt mixtures, we have a diverse pool of test methods ranging from mechanistic fundamental test to monotonic static loading-based tests. The fundamental tests are not good candidates for production level testing due to the time it takes to complete the tests. The fundamental tests are also not favored for logistic reasons: the cost of equipment, the complexity of the test, the need for a trained personnel, etc. Simulative tests are empiric tests that are relatively faster and less complicated tests compared to fundamental tests. They have also shown to be correlated to the field performance. Hence, they have been preferred by many agencies to evaluate the rutting potential of asphalt mixtures. Many agencies are moving towards using hammer wheel tracking test because it can provide information on moisture susceptibility of asphalt mixtures in addition to the rutting potential. VDOT requires APA test as part of the BMD process, and there's going to be a presentation about it in this webinar. There are also monotonic loading-based tests to evaluate the rutting potential of asphalt mixtures. The top 2 tests, indirect tensile test at high temperature and ideal RT test, are gaining popularity because of their simplicity, the speed of testing, the cost of equipment, and the fact that the same loading frame can be used to perform rutting, cracking, and moisture damage tests. VTRC will soon publish a report recommending these 2 tests for evaluating rutting potential of asphalt mixtures. So please stay tuned. This figure shows the survey results conducted towards the end of 2020 by ANCAT. 15 states are using hammer wheel tracking device for evaluating the rutting potential of asphalt mixtures. That is because of the convenience that the susceptibility of mixtures to moisture-induced damage and rutting can be obtained at the same time. 5 states, including Virginia, use APA, and 2 states are using the IDT test at high temperature for rutting evaluation. To test cracking potential of asphalt mixtures, we also have a diverse pool of test methods ranging from fundamental tests to monotonic loading-based tests addressing different cracking modes such as reflective, fatigue, and low temperature cracking. Fundamental and simulative tests are not generally favored by the agencies for the same reasons indicated for the RUT test, especially for the production level testing. This slide shows some of the monotonic loading-based tests for evaluating cracking potential of asphalt mixtures. Again, in addition to indicating correlations to the field performance, these tests are commonly used by the agencies because of their simplicity, the speed of testing, and cost of the equipment. V.BMD spec requires indirect tensile test as outlined in ASTM D8225, also known as ideal CT test. This figure shows the survey results conducted towards the end of 2020 by ANCAT. We see majority of states are using IDT cracking tests for evaluating the cracking potential of mixtures. That is somewhat expected as this test protocol does not require cutting and coring of asphalt specimens, in addition to the previously mentioned benefits of monotonic loading-based test. As our final distress mode, moisture damage, we also have a good selection of tests for the moisture damage evaluation of mixtures. The most common test for this purpose is indirect tensile strength test, also known as TSR test, and performed in accordance with AASHTO PP105-20. This is the test method specified by VDOT. This slide shows the survey results conducted by ANCAT in 2018. As we can see, TSR test is clearly the most common one. However, several agencies are switching to the Hamburg wheel tracking device as it can provide information on rotting and moisture damage potential of asphalt mixtures at the same time. With that, I conclude my presentation. Thank you for listening. If you have any questions, please feel free to put them through the chat box or ask them during the Q&A session, or email them to me at email shown in this slide. Thanks again.